the mobile phone chargers in India works in AC and DC both. Now we need to understand how or why this works in both AC and DC. Like it works with 230 or 240 volt AC single phase. It also works in, suppose our trains provide 110 volt DC. So the mobile charger works in both. Why or how? So for that, actually normally we know from our past or from the books that earlier it used to be like this, the mobile charger or any charger, in that case adapter, that some 230 volt or 220 volt AC is coming, then there is a transformer. This was earlier, it was like this transformer is a step down transformer, and step down to this voltage is here only maybe 6 volt or 5 volt. Then there is a bridge rectifier. I am showing only, suppose I am showing only this one, full wave rectifier. So actually bridge rectifier was there. So then between these 2 points, actually let me draw it here, this point and this point. Between these 2 points there are some filter circuit. So this is rectifier circuit, and then there are some filter, maybe pi filter, C filter. So that is basically some capacitor in the parallel and maybe some inductor, and then finally this is required voltage, maybe suppose 6 volt. So in case of mobile it is 3.7 volt and maybe 1 ampere. So finally this is what we actually know or normally read, that this is how a mobile charger works, or a mobile charger has this kind of circuitry. Or when we design a battery adapter or charger, we design like this. So this is rectifier circuit, this is the transformer, we can say step down, and then this is the filter circuit. But let me tell you that modern chargers don't use all this. What modern chargers use, that they use SMPS, switch mode power supply. Switch mode power supply, and this has many advantages. One of these advantages that it can work with a wide range of voltage like 230 volt, and it also can be designed to work with AC and DC both, and the losses is very less. When we from very high voltage to low voltage, the losses is very less, and this switching is actually done using some kind of transistors. So what happened, let me draw the block diagram. Actually there is first what it does. Another big problem with this design is that when the transformer size or core size, actually we can write transformer size is basically inversely proportional to the frequency for which this is used. So for a transformer of frequency 50 Hz normal supply voltage, the transformer size will be very large, very big, with respect to if this is, suppose this is 20 kilohertz, that is 20,000 hertz, then the transformer size will be very small than this. So what if we do this kind of design, then the transformer size will be very high for 220 volt 50 hertz supply. Now let's see the next, what modern charger use. They don't have this kind of big bulky transformer. So what they do, they actually take the input as 220 volt AC 50 hertz, or it may be 110 volt DC. Then if the input is AC, then it does what it does, it does a filter rectifier circuit. It uses rectifier, normal rectifier circuit. It doesn't do any kind of voltage reduction, step down operation, no. So it get actually 220 volt DC. Then what it does, it then converts this DC using some DC to DC converter. It actually create a switching operation and create some AC here, low voltage AC. This AC is not, as we know, normal AC. Here are some switching operation, converter and switching. This switching is basically nothing but using transistor and very high frequency switching. We can say very high frequency switching. So we get a high frequency AC. This frequency is, this AC may be 5 volt, but switching frequency is around 20 to 30 kilohertz. So very high frequency switching AC. So for that matter, sometime we can directly get 5 volt, or sometime we get 220 volt very high frequency AC. Then we use some switching transformer. This is another, suppose, step down transformer. This may also happen. That depends on the circuit, what chip we are using, that may have this part or may not have. So suppose if there is some switching transformer, then this transformer, what it will do, it will step down to 5 volt, and there I have a filter circuit as before. Filter circuit, filter. So filter will give us required voltage, suppose 5 volt 1 ampere. Now what is happening, actually the advantage of this is, one advantage is that this is a 20 to 30 kilohertz frequency transformer, RF transformer kind of radio frequency. So high frequency transformer, we know that frequency, as frequency increases, the transformer size decreases. So this transformer is very small in size, and so then this. So that is one advantage. Another advantage is that as we first convert AC or DC whatever to DC. So if we directly apply DC, then that this DC directly comes here without this rectifier and filter. So whatever we apply AC or DC, so at this place we already have DC. Now once we get the DC, then this DC converter is used. So this is basically DC to DC converter. This is basically DC to DC converter. And what it does, it actually, this signals, this AC is not a sinusoidal AC, but this is kind of square wave, this kind of AC. And so when we are generating different voltage or different power, so it becomes very easy. Losses becomes loss, due to only the loss will be where? The loss will be at the transistor switching operation. During the transistor switching operation, only on operation, the current will flow and there will be some heat. So loss will be very less, and the wave will be square wave, and the average value of this square wave will be basically the voltage output. So once we do this, if the switching transformer is there, then we get low voltage, or we can directly, using this kind of duty cycle, time it is on, time it is off, we can control the average voltage here also. So anyway, we get finally, if we use this one, then we get this 5 volt, and this is basically AC, so we have to again filter. So using filter circuit, we get this voltage. And one more circuitry in the SMPS or the mobile charger remains there, that is, there is some feedback path from this to the, there is, we call it as a controller, or voltage controller is there, controller. What it does, it actually controls this area, this switching, so that always output voltage, we get a stable output voltage. Whatever changes happen this side, maybe to 20 volt, maybe to 40 volt, or 110 volt DC, this side we always get this voltage. So basically this is what happens in actual mobile charger, and that is why it works in both AC and DC. Classical approach of like using this transformer is not actually done here. It was actually done earlier, more than 20 years ago it was used to be, but currently the mobile charger use this kind of architecture or this kind of design. So this is how it is works in AC and DC both. Thank you.